It's 1978. A dump truck rumbles to life before sunrise. Cold air, heavy load, no mercy. The driver turns the key, and the engine doesn't hesitate. No drama, no smoke, just a deep, steady rumble that sounds like it could run forever. He's done this 1,000 times before, and he'll do it 1,000 times again. Because this engine, it doesn't complain, it doesn't overheat, it doesn't leave him stranded on the side of the highway wondering what went wrong. It just works. And here's the strange part. That engine was never meant to be famous. It didn't win races. It didn't power muscle cars. It wasn't in magazines or posters on bedroom walls. Kids didn't dream about it. Collectors didn't chase it. Enthusiasts didn't argue about it in forums. It was invisible. But what almost nobody knows is this engine may have been one of the toughest, longest-lasting V8s America ever built. This is the story of the Chevy 366 Tall Deck, the engine America ignored, but trusted with everything. And what happened behind the scenes? It changes how you look at durability forever. Because this wasn't just an engine, it was a machine built to survive abuse that would destroy almost anything else. A machine designed for one purpose: to never give up. To understand the 366, you have to go back to a time when trucks weren't about comfort. They weren't about leather seats or touchscreens or backup cameras. They were about survival. Late 1960s. America is building highways, cities, infrastructure. The country is expanding faster than anyone can keep up with. Trucks are hauling heavier loads than ever before. Construction projects, deliveries, school routes that stretched across entire counties, and General Motors had a problem. A big one. Their small block V8s were quick, efficient, great for cars, perfect for Corvettes and Camaros and everything that made headlines. But under constant heavy loads, they wore out, fast. Bearings failed, oil overheated, blocks cracked under stress. Engines that worked fine in cars simply couldn't handle hours of full throttle abuse in dump trucks and school buses. It wasn't a design flaw, it was a limitation. These engines were built for bursts of power, not endless grinding work. And that difference? It mattered. A muscle car might see full throttle for a few seconds at a time, a drag race, a highway merge, a moment of fun, but a dump truck hauling gravel up a mountain road, that's full throttle for hours, day after day, week after week, and the engines couldn't take it. So engineers at Chevrolet Truck Division asked a simple question. What if we stopped chasing speed and built an engine that simply refused to die? What if durability wasn't a feature, but the entire point? That question led to something radically different. Instead of designing a high-revving performance engine, they went in the opposite direction: thicker, heavier, stronger. They didn't care about weight savings, they didn't care about top speed, they didn't care about magazine reviews or racing credentials, they cared about one thing: survival. The result was the tall deck big block platform, and sitting right at the heart of it was the 366 cubic inch V8. But there was a catch. This wasn't just a smaller version of a 396 or 454. This was a completely different philosophy, a completely different approach to what an engine should be. The 366 used a 4.06-inch bore and a 3.76-inch stroke, giving it 366 cubic inches of displacement. On paper, that doesn't sound impressive. Compared to the big names of the era, it looked almost boring. But look closer, because the magic wasn't in the displacement. It was in the architecture. The block itself was taller than standard big blocks, about 0.4 inches taller to be exact. That doesn't sound like much. Most people would glance right past that specification. But it changed everything. That extra height allowed for longer connecting rods, better rod angles, less side loading on the cylinder walls, which meant less wear, less heat, less friction, and a dramatically longer lifespan. See, in engine design, rod angles matter more than most people realize. When a piston moves up and down, the connecting rod pushes against the cylinder wall at an angle. The sharper that angle, the more friction. The more friction, the more wear. The 366's taller deck gave those rods more room to work, a gentler angle, a smoother motion, less destruction happening inside the engine with every single revolution. It was elegant in a way that didn't make headlines, but it worked. But there was a problem. Actually, several. Because making an engine stronger often makes it heavier and slower and less exciting. And that's exactly what happened. The 366 wasn't fast, not even close. Most versions produced around 200 to 250 horsepower. Torque numbers sat in the 300 to 350 lb-ft range depending on the configuration. In an era when muscle cars were pushing 400, 450, even 500 horsepower, this thing looked weak, slow, almost embarrassing by comparison. But that's missing the point entirely, because this engine wasn't designed to win races. It wasn't designed to impress anyone. It was designed to survive punishment that would kill anything else on the market. And the engineers doubled down on that idea in every single detail. The crankshaft was forged steel, not cast, stronger, more expensive, built to handle constant stress without fatigue, the kind of crankshaft you'd find in racing applications. But here, it wasn't about speed, it was about longevity. The pistons? Heavy duty, designed for longevity, not lightweight performance. They weren't trying to reduce rotating mass, they were trying to build components that could take a beating. Compression ratios were kept low, around 8:1 or even lower in some versions. Why? Because lower compression meant less heat, less stress on every component, less chance of detonation under load when the engine was working hard hour after hour. High compression makes power. Low compression makes survivors. They chose survivors. And here's where it gets interesting. The 366 used a unique cooling and oiling strategy that prioritized survival over everything else. Oil flow was designed to keep critical components alive under constant load. The passages were engineered to maintain pressure even when the engine was working at its hardest. Even at lower RPMs, where many engines struggle with oil pressure, the 366 stayed stable. It didn't spike, it didn't drop, it just held steady. One mechanic reportedly said, "You could run these things all day at 3,000 RPM and the oil pressure wouldn't even flinch. It was like the engine didn't even notice it was working." That kind of consistency doesn't happen by accident. It happens by design. But even with all that, there was still a problem, and it showed up when these engines were pushed beyond their limits. Operators started reporting something strange. Not catastrophic failures, not explosions or seized bearings or dramatic breakdowns. Just slow wear in specific areas. Cylinder walls, valve train components. Nothing dramatic, just fatigue over time. Components wearing faster than they should have been. It was subtle, easy to miss if you weren't paying attention. But the engineers were paying attention, so they went back to the drawing board. They studied the failures, analyzed the wear patterns, looked at what was happening inside these engines under real-world conditions, and what they discovered changed everything. The issue wasn't the strength of the components, it was the environment. Constant heavy loads meant constant heat buildup, and heat is the silent killer of engines. Not the dramatic kind of overheating that blows head gaskets, the slow, insidious kind that warps metal over time, that causes uneven expansion, that creates stress points where there shouldn't be any. So they made a subtle but critical improvement. They optimized cooling passages in the block and heads to improve heat distribution, not just removing heat, but controlling where it went, because uneven heat causes distortion. And distortion leads to wear, and wear leads to failure. By managing heat more precisely, they reduced distortion, and by reducing distortion, they extended life. It wasn't flashy, no one wrote articles about it, but it worked. And once that fix was implemented, the 366 became something else entirely. A workhorse that refused to quit, a machine that could take everything the world threw at it, and ask for more. By the 1970s and into the 1980s, the Chevy 366 was everywhere. School buses, dump trucks, delivery vehicles, medium-duty trucks hauling thousands of pounds every single day, utility vehicles, construction equipment, anything that needed to work hard and work constantly. These weren't glamorous applications. No one took photos. No one bragged about them at parties. But they were essential. And here's the part most people never hear about. These engines didn't just last 100,000 miles. They routinely pushed past 200,000, 300,000 miles. Some even went further, much further. There are documented cases of 366 engines running over 500,000 miles with basic maintenance. Think about that. 500,000 miles in vehicles that spent their entire lives under load, stop-and-go traffic, idling for hours, hauling weight up hills and down mountains, operating in summer heat and winter cold, conditions that destroy most engines in a fraction of that distance. And yet, the 366 kept going. Fleet managers started noticing patterns. When they ran the numbers, the 366 powered vehicles consistently outlasted everything else in their fleets. Maintenance costs were lower. Downtime was minimal. The trucks just worked. But there's a reason you've probably never heard anyone brag about it. Because it wasn't exciting. No one was drag racing a 366. No one was putting it in a Camaro or a Chevy. It didn't have racing heritage. It didn't have celebrity endorsements. It didn't have a cool nickname. It was slow, heavy, industrial. And in the world of cars, that meant invisible. Nobody puts a poster of a school bus engine on their wall, but behind the scenes, it was earning a reputation. Mechanics loved it. They could work on it. They could understand it. They could fix it without specialized tools or complicated procedures. Fleet owners trusted it because it saved them money, because it showed up every day, because it didn't surprise them with unexpected failures. And drivers took it for granted, which might be the highest compliment of all, because it did one thing better than almost anything else. It showed up every day, without complaint, without drama, just reliability. But then, everything started to change. By the late 1980s and early 1990s, the automotive world was shifting. Fuel economy standards were tightening. Emissions regulations were getting stricter. Fuel prices were climbing. And suddenly, big, heavy, low-compression V8s didn't fit the future anymore. The 366, with its cast iron bulk and old-school design, started to look outdated. It didn't matter that it was reliable. It didn't matter that it lasted 500,000 miles. What mattered was efficiency, emissions, miles per gallon. And the 366, it drank fuel. It was designed in an era when fuel was cheap and nobody cared about emissions. That era was ending. And in a world moving toward lighter, more efficient engines, that was a problem. So General Motors made a decision. They began phasing out engines like the 366 in favor of newer designs. More efficient, more modern, better on paper, less durable under extreme conditions. But that wasn't the metric anyone was measuring anymore. And just like that, the 366 started to disappear. No big farewell, no headlines, no dramatic ending, no ceremony. It simply faded away. Production slowed, then stopped, replaced by engines that were more advanced, but often less forgiving. Engines designed for a different set of priorities. And here's where the story takes an unexpected turn. Because years later, people started noticing something. Those newer engines, they were better in many ways. They were faster, cleaner, more efficient. They passed emissions tests easily, they got better fuel economy, they looked good in marketing brochures, but under constant heavy use, they wore out faster, they needed more maintenance, they didn't last the way the old ones did. Fleet managers who remembered the 366 started comparing notes. Mechanics who had worked on both generations started talking. And suddenly, the old 366 didn't look so outdated anymore. In fact, it started to look like something we had lost, something valuable. An engine built not for performance, not for efficiency, not for test results or regulatory compliance, but for endurance, for showing up every single day and doing the job, year after year, decade after decade. Today, the Chevy 366 has become something of a quiet legend. Not the kind you see at car shows, not the kind that gets magazine covers or documentary films, but the kind you hear about in stories. Old mechanics talking about engines that just wouldn't die. Fleet owners remembering trucks that outlasted everything else in the yard. That outlasted the companies that bought them. That outlasted entire generations of workers, drivers who spent their careers behind the wheel of 366 powered vehicles, never once stranded by a failed engine. It's not glamorous, but it's real, and in a way, that makes it even more impressive. Because building a fast engine is one thing. Any company can throw money at horsepower. Building an engine that survives decades of abuse? That's something else entirely. That requires a different kind of thinking, a different set of priorities, a willingness to sacrifice excitement for reliability, and the courage to build something that will never make headlines. So why does this story matter? Because it reminds us of a different era of engineering, a time when durability wasn't a side effect, it was the goal. A time when engineers asked not how fast can we make this, but how long can we make this last? The Chevy 366 didn't win races, it didn't break speed records, it never graced the cover of a single enthusiast magazine, but it did something arguably harder. It endured for hundreds of thousands of miles, under conditions most engines couldn't survive, and it did it quietly, without recognition, without fame, without asking for anything in return, just reliability, day after day, year after year. And maybe that's why it was ignored, because it didn't need attention. It just needed to work, and it did, better than almost anything else ever built. In the end, the Chevy 366 wasn't about power or performance. It wasn't about winning or impressing or dominating. It was about one simple idea: build it strong enough, and it will take care of the rest. Don't chase headlines, don't chase records, chase reliability. That's what made it special. That's what made it last. And that's why even today, people who know still respect it, still talk about it, still remember it with something like reverence. Because in a world obsessed with the fastest and the flashiest, sometimes the greatest achievement is simply refusing to quit. If you enjoyed this story, let me know in the comments what engine you want to see next. Another forgotten workhorse, a legendary race motor, or something in between. And if you want more deep dives like this, make sure to subscribe, because the next story might completely change how you see engines forever.